question 4 of our FRQs. Now this big paragraph, a lot of space. I see the word just by glancing, convincing statistical evidence. I'm going to have to run a test. We're going to have to run a test. And it gives us two different parts. So I drew my graphic organizer here. I put info, conditions, calculations, and conclusion, and here we go. Tumbleweed. Now, we're probably going to have to spend more than 13 minutes on this one, but we'll do our best. Tumbleweed, commonly found in the western U.S., is a dried structure of certain plants that are blown by the wind. Cochea, a type of plant that turns into tumbleweed at the end of summer, is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. So scientists are concerned that those plants are becoming resistant to the most commonly used herbicide called glyphosate. Okay, this is also, turns out, someone said is Roundup. In 2014, 19.7% of 61 randomly selected cochea plants were resistant to glyphosate. In 2017, we got two groups. In 2017, 38.5% of the 52 randomly selected cochea plants were resistant to glyphosate. Do the data provide statistical evidence? We're going to have to run a test. Oh, look, the alpha is 0.05. That there has been an increase in their proportion. Proportion means z-test. Means is a t-test. Categorical data, if they would have given us that, would mean a chi-squared. This says proportion, so it must be a z-test of all cochea plants that are resistant to glyphosate. So there we go. There is my alternative hypothesis, an increase in the proportion of all cochea plants that are resistant to glyphosate. So here's our first thing. We do P of 14. We define our parts. What are our parameters here? Okay, P of 14 is the proportion of cochea plants of 2014 resistant to glyphosate. P of 17 is the proportion of cochea plants of 2017 resistant to glyphosate. We have to define our parameters here. We have to say what the 14 and 17. If you want to call it P1 and P2, that's fine. Or PA and PB, that's fine. But you have to say what those values represent. I put the 14 and 17 for me to keep them straight. So of my sample of 2014, P hat of 14 is 0.197. Q hat of 14 is 0.803. There's my N and my X. I did the same thing with P hat of 17 is 0.385. Get 0.615 for the Q hat. The numbers, the sample size was 52 and X was 20. So then here's my null hypothesis. My null hypothesis, they want to know if there's an increase. So we start out, my null hypothesis is always an equal sign. So my null hypothesis, P of 14 equals P of 17. You can write this either direction, doesn't matter to me. I went ahead and wrote alpha equals 0.05. My alternative is what's right here. Is there an increase? Has there been an increase? So is 17 greater than 14? So I wrote it, 14 is less than 17. Again, you can rewrite it the other direction. Then I did my conditions. There's a random sample of cochea plants in 2014 and 2017. My years are independent of each other. 2017 does not affect 2014. Then I've got to do my success failures. My NP of 14 is 12, NQ of 14 is 49, both greater than or equal to 10. NP of 17 is 20, NQ of 17 is 32, both greater than or equal to 10. I then do my 10% conditions. 61 cochea plants was less than or equal to 10% of all 2014 cochea plants, and 52 was less than or equal to 10% of all 2017 cochea plants. So I've already talked about it. It's a z-test. I have two different groups, so I'm doing a two proportion z-test. Got to name the test. Got to name the test. Okay, my calculations. Since I said that they were equal to here, I'm assuming they're equal. So then I'm going to have to pull these two together. This happens on the z-test, and it tells us on the formula page, if you say that they're equal, then we pull them. So 12 plus 20, my successes is 32 out of the total, the sample size of 113. That gives me my new p hat of 0.283. So I find my standard error for the group. P hat Q hat over 61 plus P hat Q hat over 52. And that gives me a standard error of 0.085. And again, folks, this is on the formula page. Okay, this is on the formula page. This is what I just found my standard error of the p-values when I say that they're equal, where the p hat comes from adding my two x's divided by the sum of the two sample sizes. Then we have to find our z-score. Okay, so here's our z-score. It's 0.197 minus 0.385. Those came from up here. Okay, that's p hat minus p hat. Now, if you said the other way around, that if you wrote p17 is greater than p14, then I would have flip-flopped these two numbers. Divided by 0.085, you run this on the test. Okay, we can run this on the test. And if you don't do anything else, you should be able to do this. Okay, stat test two proportion z test is 6. So I put my numbers in. There's my x, there's my n. There's for 14, for 17, and I said that P1, which was the 14, is less than P of 17. That's the reason why I picked less than. This, remember, this is always your alternative hypothesis. And then I calculate. If P1 is less than P2, my alternative, then my z-score is a negative 2.2095. I'm just going to round that up to a negative 2.21. There's my p-value. So the p-value that z is less than a negative 2.21 is 0.014, 0.013568. I round it up again, 0.014. So I showed my z-score, I showed my standard error, and I wrote my probability problem to get my p-value. Now we compare our p-value to our alpha. This is smaller than that. Now let me go back and say real quick, you should at least be able to run the p-test to get a p-value. Write whatever your p-value is down here somewhere, then write your conclusion. You should be able to do these. You should always be able to do your ho and your ha, and then that should be able to help you write your answer. So here's my conclusion. With a p-value 0.014 less than alpha 0.05, we reject the null hypothesis. There is evidence that there has been an increase in the proportion of cachea plants that are resistant to glyphosate. This should be a point, whether it's a t, z, or chi-squared, you should always be able to write the conclusion. Okay, now I didn't do all this writing. We talked it through in less than 8 minutes. Hopefully you can do this in under 15 minutes with all the writing. I expect there to be some type of z, t, or chi-squared test on the exam, and hopefully we can get it correct. Good luck to you on that.